László, all yours.
Hi, I'm Radnai László, and I will be talking about hacking Counter-Strike Global Offensive. I'm interested in money stuff. I'm interested in cryptography, memory corruption, mostly the offensive kinds of security. And I'm also working as a security researcher at Task, but this talk is independent research before my employment, and I want to give many thanks to Khan. I will be talking about the CSGO attack surface. What does it mean you hack CSGO? And how to script CSGO with Squirrel. This is the component where I found the vulnerabilities I will be describing. There will be a part about exploitation, and I will have a few notes on the disclosure process, as you might find on all CSGO talks. So, CSGO is a first-person shooter. It uses the source engine, and one really important thing is you can play it over local network, or you can spin up a dedicated server which runs on your machine, and it can be found globally on the internet, so anyone can connect to your instance. And also, relatedly, you can upload maps and have them officially listed inside Steam's workshop. And thus the attack surface comes that you can hack client to server, client to client, or server to client. This means that I am a malicious actor. I spin up a CSGO server, and anyone who tries to connect is the client binary is hijacked, so it executes some stuff instead of like the game itself. So I can install malware or stuff like this, and this part is also like you can also use user-provided maps for this exploit. And anyone who tries to spin up a server with it is hacked. There are surprisingly many public research here, so you can just search for it. In maps, there are various ways to include some malicious stuff and try to find vulnerabilities that are present when parsing maps. And when you connect to a server and the map is not on your machine, the client automatically just downloads it and trusts it completely. So you have, you can attack specific resource parsers here. And what I did was finding bugs in the Squirrel interpreter engine. Now, the Squirrel is a scripting engine for creating complex game logic, not part of the original CSGO game. And anyone can create plugins, embed them in maps. You just have to put this file into a specific path. For testing, you can also just put it on the matching path. You can create a mapscript.net, and it gets automatically executed for any map you host, or you can embed it in a map, and anyone who hosts this map is running this script. However, this talk is not about Counter-Strike 2. It uses Lua instead, if I'm not mistaken, and the component is not even present in the CS2. This map script is called at load time. So when you load up the map, one of the first thing that runs is this map script. And when we are talking about game logic, it happens on the server. So when you create a script, it runs on the server, and any changes are pushed to the clients. However, for some reason, the client also runs this math script locally, but without any APIs to access the game's logic. So it would be reasonable to disable this on the client side. So no developers use it, only attackers. And this talk gets to the deep dive into Squirrel. This is a lightweight scripting language for applications like video games. It's open source and really similar to Lua in many ways. But Valve disables parts of the Squirrel standard library. So you don't have access to files or call out to shell. You don't have arbitrary code execution as a given here. Also, Valve's distribution in Squirrel is not the same as Squirrel. They maintain a really old version, and they have their own patches on top of the Squirrel's main code. So are these safe? Do they backport security fixes? And the answer is sadly that the patches are vulnerable and they do not backport important security fixes, which I will demonstrate. I've created Squirrel CLI and backported the vulnerabilities I have found to the open source project for this presentation. And when you have fun playing with Squirrel, note that, like hacking Squirrel, note that on CSGO, the Windows is a 32-bit build, and in Linux, this is a 64-bit build, but both are exploitable. When I was getting to know this whole Squirrel stuff, I found that it's really easy to crash this Squirrel. This was like surprising. This is not what happened in real life. What happened, I popped up the console of CSGO and written these commands. And this crashed the whole CSGO binary. And if you would embed this into a map, it would also crash anyone's client. But this is nothing interesting. This is just denial of service. You cannot play this map. Okay, what can I do then? So I found multiple vulnerabilities. From the security bugs I found, one is a feature, two are end days, and one is only a denial of service, 2 0 days in CSGO, and 1 0 day in Squirrel. The last one I won't be talking about today, sadly. I have found these bugs independently, but it can be seen that these were already end days fixed long ago when I found these vulnerabilities, some of them. So 2 of them were public. I will start with the denial of service bug, but the important part here is the introduction into exception handling in Squirrel. When you try to calculate division and the second operand is 0, it will raise an error division by 0 instead of calculating the result. And you can also catch this exception and use it as a string. So this is just any string that you can access inside Squirrel. It's the same. For this specific bug, let's imagine 3-bit signed integers. in two complements form, these can represent any value between -4 and +3. So -4 has no positive counterpart, and this has interesting implications. The absolute value is negative, for example. This is pretty fun stuff. Just look some vulnerabilities like in these kinds of code. But it actually crashes on x86 when you try some invalid operation with division and remainder operation. So when you calculate 1 divided by 0, there is a case. So there is a case that, okay, instead of calculating the result, raise an exception. But this is not present for the other case. So if you take the smallest negative integer there is and divide it by -1, the whole program crashes. This was fixed long ago by upstream. I've never bothered to report it to Valve because this cannot be weaponized further than DOS. Now, another vulnerability, which is probably by design, is that you can have some kind, if you print some kinds of objects, for example, arrays, it prints the row pointer value on both Linux and Windows. This defeats a security feature where pointer values, like regions, are memory layout is randomized, so you cannot guess a pointer. And you can also script this in an exploit. So the exploit I will be talking about is the exploit I will be talking about will be a script which locally runs on the victim's machine, and there it exploits these kinds of vulnerabilities and gain remote code execution. So we have to create a script, and we must access the value, the pointer value, based on the this string. For example, we can write a small tool called unhex, small function called unhex, and this was really fun exercise. Like half of it was re-implementing like standard stuff, converting between bases like hexadecimal and integer and bytes, and half of it was building complex primitives from the vulnerabilities I found. This was just an excerpt in the previous slide. And next is the type confusion bug. Now, you can throw your own exception. You can throw any string, and it will work just as you would expect. So it prints an error has occurred ASD. You can, and there is a separate feature, this was developed by Valve, that if you create an invalid operation between a string and integer arithmetic operation, then it will include this, what I call a reason string, which queries the last exception and includes it in the new exception. So it wraps this string. But what happens when you throw an integer? Squirrel's interpreter is smart. It prints an error has occurred, unknown. This is because it tries to print it, and then it looks at it and, yeah, but this is not a string. So let's just print unknown and get on with it. However, this was not implemented by Valve, like not handled by Valve, and it trusts this value without verifying it. It trusts the type of the value without verifying it. So actually what happens, it tries to copy a string from the address hex DADA plus hex 38. Now, when you look at what happened, the right hand is for C developers, but I will explain on the left side for anyone else. So you have kind of a tag and a value. All objects are stored as a tag and a value, and the tag defines what the value represents. For integers, the row value, it is the row value. For any other type, this is a pointer to the exact structure representing the object. And the exceptions here are assumed to be strings within Valve's patch. So the confusion comes because the tag is not compared against OT string. And another thing I want to note is that every SQ string, when you allocate it, it is allocated with the object, with the string contents next to it. This means that at hex 38 offset is the actual string contents. So you can actually leak data at any address you want. For example, if you don't have ASLR, you can leak the elf header like this. But we also have an ASLR bypass, which makes it a reusable arbitrary memory read primitive. So this is pretty powerful. You can read anything going inside the CSGO client. Next step is how to corrupt the memory. Now, the first interaction I showed was actually a heap buffer overrun. And this is also present in Valve's version of Squirrel only. This is heap, so I want to note that the heap allocator is dlmalloc. You can do stuff like that, stuff like heap method corruption, but we will not be talking about this. So let's run the script line by line. We try to run this, calculate this value. This is an invalid operation, so it says an error has occurred, arithmetic operation. Reason, the index doesn't exist. The next line is arithmetic operation failed, reason, arithmetic operation failed, next line, and the index doesn't exist. So where is this going? Some buffer is limited, and it can be because of a string formatting, target buffer is limited in size, or this can happen when the error is put into an SQ string, so it can be accessed inside the script, or when printing the error string to the user. What actually happens is that the string formatting uses sprintf, and a weird quirk of like a code pattern used by Squirrel's author is that every error is assumed to be limited in size, and depending on the format string which you use, it's always the format string's length plus 100 characters. So for this exact string, the format string's length is 41 bytes, and it is assumed that the developer doesn't do stuff like include more than 100 characters in any of the format parameters. And if you expand the macros, only then you will see that this is actually using sprintf. So T1 and T2 is the type names like string and integer. These are limited in size. I think the Squirrel's author has known about this and used this feature wisely. But Valve developers didn't know about this quirk. It's not documented anywhere. And another thing is that this is the exact place where the type confusion bug happens. In the previous line, probably, the last error object is implicitly casted into an SQ string, and its value is used as part of the sprintf operation. But I didn't explain the get scratchpad. This is temporary storage for string manipulation, like doing some quick formatting before doing some actual stuff on this result string. It has one instance, and it is dynamically allocated, and every time you use it, it decides whether the previously allocated version is too big or too small, and it grows or shrinks based on whether this is too big or too small. So this is used by two features, as I found. One is string concatenation, and the other is this like sprintf on steroids pattern. You can use this scratchpad, like you have an operation, get me a scratchpad of size X, and this is basically the whole interfacing. If you request some data of rec bytes, if request a buffer of rec bytes, the buffer is too small, you allocate a bigger one. If the buffer is too big, like 32 times as big, you have the actual size, and it still fits. So if we can control the previous size, we have a much larger range. We have a large range where this allocation, so this reallocation doesn't happen. It just straight up returns always the same buffer. When you script this into an exploit, I will show you some POC. You set the last error by throwing the exception and swallowing it. Sorry? You swallowed it, but the last error still points to this string. You shape the scratchpad size so it will be too small. For example, we can trigger getScratchpad1 through stringcat by calculating empty string plus empty string. And then, if we know what the next allocation is, and we write data we want into this next allocation, we can actually do that. So this buffer is overrun, it only prints 200, and it allocates 211 bytes, but we can print more data into it. So if we can make an SQ string be located after this object, then that object will be overwritten. We will use something called vtable override, vtable pointer override, which defines the implementations of the virtual methods. So this is like a C++ quirk. However, how do we shape the heap so that the scratchpad and this SQ string is allocated next to each other? We allocate 100 strings, and then we delete one. Probably these strings will be aligned next to each other in the memory, and when you create a hole and trigger the corruption by this primitive, the hole is filled, and the next allocation gets corrupted, and it's probably the next element in the array. There are other quirks. For example, you have to create distinct strings for each string object, and more advanced heap shaping can be used to be much more certain on the effect of this allocation. So you can be pretty sure that the next allocation will be here, and it will override this bytes of this object. For the exploit, I want to note that we still can use the type confusion bug to read any kind of data from anywhere by going through the right pointers. And we can also create a fake vtable. For example, by creating a raw SQ string, it can include any kind of characters. And the exploit starts with heap shaping and triggering the heap buffer overflow. Then the SQ string object is corrupted, and if we can trigger the victim's overwritten virtual method, for example by removing it, which calls a function called release, removing all references to this object, then the vtable pointer is used to overwrite so the vtable pointer is used to find the virtual method. This is corrupted. We have this pointed to a fake vtable, and the virtual method, calling into virtual method means jumping into an address vcontrol. So a fake vtable contains an entry for a single gadget stack pivot, and it basically just swaps the stack pointer with some register vcontrol. And this means that when you next return to the next function, you return to a fake stack. And this fake stack contains a rope chain, and this exploit I will be showing will open calc.exe. Of course, in real life, you have much more powerful demonstrations. This is just arbitrary code execution demonstration. So this demo won't be able to show this, but we will be creating a fake vtable. We will be creating a rope chain, which is a fake stack. And we overwrite an SQ string and trigger the release function, which is hijacked by us because of the fake vtable pointer. Okay. So here, this command bspzip, sorry if it's not visible, bspzip is a utility for a map editor. You can include any type of resource within a BSP file. This is what it shows. And we create a poc.bsp. This is the maps format. And we start a dedicated server with this map. I will jump into it if I can. So you can create a dedicated server with a Steam account token, and I've already initialized CSGO, and you can find this server. You could have found this server on CSGO back when this POC was created. What happened here, I just filled in, let's connect this, and this is password protected, so random people aren't getting exploited in the internet if they want to join. And you know, I cannot show anything that, yeah, creating fake vtable, it just pops up a calc, it's instantaneous. So this is the PLC. So in conclusion, I found that vtable override is powerful. You don't need to think about heap allocation too much. If you can target these 4 or 8 bytes, you just need some somewhat special gadget, the stack pivot gadget, and you get a full rope. Interpreter removes much of the uncertainty. So if compared to like network attacks, you don't need to think too much about how do I shape the heap so that it's robust, so that the POC is robust. On the defense side, I think that ESLR would have been really helpful here. This exploit, as it was, could not work, and this was bypassed by a feature. CFI would have been helpful, but this was not built with CFI option. This control flow integrity basically just builds some checks that when you want to jump somewhere in between the code, you jump into a normal place, as normal as it can be. This would mitigate the rope chain. It would have made it more difficult, and the vtable protection is probably, I think it's doable. Somehow protecting the vtable and not letting it point to some random part on the heap. And there was this is my favorite bug. It just straight up doesn't work, because if you want to have a string and this Pythonic negative string indexing would read from the end of the buffer, but what you actually have is it always overflows when you put a negative integer there, because the sign is messed up. I've submitted this bug almost 3 years ago, and it was 1.5 months before it was forwarded to Valve. So HackerOne mediates every request, every security bug, and they are basically the level 1 security people outsourced. So if you report a bug, you have to demonstrate the POC before it gets sent to actually someone working at Valve. And this was 1.5 months where there was this back and forth that, yeah, I couldn't reproduce it. Can you build something so that I can reproduce it? Basically, how to deploy the server, the client, how to connect the client to the server. Valve only responded 1.5 years later and paid bounty, and basically that was it. And it was another 5 months, no, 4.5 months, where this was addressed. And when I say addressed, it meant that, yeah, we thrown CSGO into the trash bin. So there, it won't be exploitable. But note that if you download CSGO, then it says that, okay, you cannot, I don't know, connect to a community server. This is not supported. Update to CS2, please, please, pretty please. So, yeah. This is in contrary on this, so what I have showed is contrary to HackerOne statistics, and I'm not the only one who showed disclosure timelines similar to this. I think that this was probably because the statistics include invalid bugs, which were closed by HackerOne staff, so not even getting to Valve so that it can be triaged. Also, and I want to note that community server to client is less serious than client to dedicated server or client to client, and they are assigning a reduced priority for stuff like this. So this may be important part on why this was like slow. And basically that's it. Hacking interpreters are pretty fun. I recommend you try hacking around with this. This is really great, and I would like to thank you for listening to this talk. Thank you.
I'm not sure how Valve usually does this, but why didn't you reach out to Valve directly instead of going through HackerOne?
So this is their official way. When you want to report a vulnerability, it goes through HackerOne. This is for bug bounty, so you get paid for this, and this is like an inconvenience for researchers. But you cannot bypass this, basically.
Okay, so what kind of debuggers can you use with CSGO, like WinDebug, or what's working for you when you are exploiting some stuff like that? Because you mentioned that you were like re-implementing all the bug fixes, like reverting them, I assume, to reproduce the vulnerable version of Squirrel. But I assume that for a heap exploit, you probably need the actual game to see what's going on to be able to debug. And what kind of software can you use for CSGO specifically?
Okay, so the question was about how did I debug this? How can I develop an exploit for this? And about the closed source nature, you can, so the most important thing is that this is compiled into dynamic library vscript.dll or vscript.so, depending on the platform. So you know where the stuff is you want to search for. You open up Ghidra, find some function, and go around these references that, oh, I know where this arithmetic operation string is, search for it, and then just iterate and reverse engineer. I think they have no symbols compiled in, only the exported symbols. So this is so this is half of the answer. The other half was about how to debug your solution, which is WinDebug. For me, it was GDB on Linux. It was WinDebug on Windows. I've first done this exploit for Linux, then ported it to Windows. And also I think actually at one point I ported the SQCLI with the vulnerabilities I have already found to have like a less complex heap pattern and try to reproduce the bug there and then go on to the real target.
Okay, thank you.
Just another one here.
You don't have to answer if you don't want to, but how much bounty did you get?
It was, the bounty was late, but I wasn't so unhappy about the amount.
Okay.
Good answer, László.
Did I understand correctly that CSGO still did not patch the bug? So if I connect to a server, I may be infected, theoretically speaking?
Okay, I think you can currently only connect to a server through getting in the console and print and execute connect IP address port. So I think this is not So theoretically, you could be exploited, but when you try to run CSGO, it will try to update it. They have a beta feature where you can play CSGO, and there you don't have access to this community server listing in the graphical interface. But yes, this affects the last version of CSGO. I have verified this.
Out of curiosity, I haven't played CSGO at all, only earlier versions. It was a thing back then to have cracked servers all around the world. Is it a thing also in CSGO as well? So some servers may be infected, like only in the cracked, society?
So is there some kind of popular map that still exploits these vulnerabilities I've described or similar ones? I have no idea. I don't know how to start this research even, but we can talk about this after.
Cool, thank you.
Is there anybody else with a question for László? No, if not, László, again, thank you very much. We close this session now.